Good day friends, how are you all? Today we are going to discuss about the most important and happening topic these days on internet, that is nothing but quantum physics. Now it has become more popular because Nobel Prize in Physics of year 2022 has been declared and has been awarded this year, right? And it has been shared by three genius scientists. They have discovered the theories and the secrets of quantum mechanics. Now the point is, what's quantum mechanics? To understand this, first of all we need to understand the difference in field of physics. The initial, or basically you can say the time when we have started understanding physics, all those part, that is known as classical physics, and the modern physics, that is basically the quantum physics, right? Now in classical physics we have studied mechanics, we have studied rocket science, we have studied aerospace engineering, we have studied a lot of things, thermodynamics, SHM, simple harmonic motions, right? All these things are known as classical physics and they come in classical physics. Now classical physics can be understood and observed very easily if we use our brain, right? So basically this is a common saying that whatever things are going on in your surroundings and in your cosmos, that all can be understood and they all are based on certain laws of physics, right? But when we talk about the quantum physics, so then the all theories that we have studied and that we see in our daily life, all are totally failed in explaining the concept of quantum physics. Now why it is there? Because at quantum level the properties of a material or matter are totally changed, right? Now why it is so important? Because if we are able to understand quantum physics and we are able to do a lot of research on that, and if we are really able to apply it, so then there is a possibility that we can communicate through a long distance that can and that could never have been achieved so far. Don't you think it's very strange? Yes, of course. Let's suppose if we are able to establish a correlation between two particles, so the communication can be established between those two particles if one of them is kept in the earth and other must have been kept in Jupiter or in Mars or any other planet. Now can you understand that by the help of quantum physics we are able to establish a communication between two particles which are separated through a very long distance, right? So let's try to understand that what is quantum mechanics all about and what are the theories and how these theories are totally different from classical physics. Now in the year 1956 there was a genius scientist named Bell. He gave an inequality that there must be some hidden variables, right? And these all are limited, right? So people have started doing a lot of experiments, but those days we didn't have too much well equipped lab and tools by which these things can be tested and verified. Later, some of the scientists, they took a challenge and they started doing research work on it, right? And then slowly and slowly people have realized that there is something that we need to keep on working out, and then we will be able to establish a correlation between the two particles, right? Now to understand this, a common theory was given by the scientists who were really working out on quantum physics. They said that let's suppose we take a device, right? We take a device in which what has been done? It throws a balls. Now let's consider that there is a device that throws two balls randomly, right? And there are two observers, right? Person 1 and person 2. Now what will happen? And let's suppose for a particular instant, if this device throws a white ball towards person 1, so at the time when he catches the white ball, he will immediately understand the black ball has been thrown by this device to another person. Is the point clear? And vice versa. Means let's suppose the person A gets a black ball. So immediately he can understand that the other person must have got the white ball. Right? Now, let's talk about it in a different way. Then the question arose in such a way that whatever colors, if we see, do they really exist at the time when it is not observed or it is not thrown from the device? So then people have realized that at the time when the balls are not thrown, so then the colors of the balls are grey, right? But when they are received by either of the persons, so then the color gets changed, right? You can see the diagram and you can understand it, that basically what has been said in this particular theory. Now you see that there is a device which throws the ball randomly, right? And we have two persons, person 1 and person 2. Correct? Now for a particular time, let's suppose that the ball throws one ball towards person 1, another ball towards person 2. Right? So at the time when person 1 receives a white ball, so he thinks that yes, of course, the black ball must have been thrown towards person 2 and vice versa. Correct? Now some of the scientists said that are there some hidden variables to identify these incidents? Even the great scientist Einstein had also this perception that there must be some hidden variables, some hidden theories are there which we are not able to identify in establishing and understanding the quantum mechanics. Right? Even for instance, he was not able to accept that yes, quantum physics really exists. But the youngster scientists, the scientists of young lobby, they really understand and they had a acceptance that of course the quantum mechanics exists. Right? Now you can see here that if we are able to identify and understand quantum mechanics, so it is a possibility, there is a possibility that we can establish a communication between two particles, and even if they are kept at a very long distance, right? And we need not to have or maintain any contact. Means let's suppose if both the two particles are entangled in such a way, now this theory is basically known as entangled theory, right? Now what is entanglement all about? Now this can be understood by taking two waves. Let's suppose we have two waves. So we have studied in wave theory that there is something known as interference. Means let's suppose we have one wave and we have another wave. Means we have two waves. Now two waves both are having different amplitude, different time period, and of course the different frequency. Now let's suppose if the interference occurs between the two waves, so the resultant wave may have a different amplitude and different frequency, right? So that entanglement theory can be understood by the interference of wave. That let's suppose if we have two devices in which there are two pairs of particles, and let's suppose one pair of particles are entangled, so the other two can be entangled and can be paired even if there is no connection between both the two. Means we are able to establish a communication between the two particles even if one particle is kept on the earth and the other particle is kept on any of the planets, right? So if the position and the state of particle A is changed, so ultimately the state and the position of another particle can automatically be changed. And that's the application and role of quantum mechanics. That this is highly helpful in developing a quantum computers that will be much higher, and the performance will be much higher than the present days computers that we have, right? It will be highly helpful in developing a quantum network over the particles, right? So definitely in future we will be able to establish a secure connection between the two particles kept long distance away, right? So thanks a lot for watching this video, and stay tuned, and next time wait for the next video so that we will be discussing more and explaining more about entire physics. Thanks for watching. Thank you.